The next video in our mole unit is titled Percent Composition. You can see we have two learning targets here. We want to be able to calculate the percent composition of a compound from its formula and also use percent composition as a conversion factor. And as always, you can see a list of resources here that you can access if you so choose. The whole key idea of what we're doing here, percent composition, or has several other names. Percent composition would be one of them. Percent by mass, mass percent. All these are the same thing. It's always equal to the mass of some element divided by the mass of the compound that it's in. So it's a ratio, and then we just multiply it by 100 to give ourselves a percentage. So that would equal the percent composition. So I just want to jump right to some of the examples here so we can see how this would work. The first question, we were asked to calculate the percent composition of each element in barium sulfate, BaSO4. So let's just start with the barium. If I'm going to find the percent composition of barium in this, I'm going to take the mass of barium divided by the mass of the whole compound. Well, we're not given any information about how much compound we have, so it's easiest just to assume that I have 1 mole. Assume 1 mole. That way I can just use molar masses. So use molar masses. So just like I were calculating a molar mass that we've learned how to do, I'm going to use that same process here to find the percent composition. I can see in 1 mole of barium, or 1 mole of barium sulfate, there is 1 mole of barium. So if you just look at the periodic table, you'll see the mass, molar mass of barium is 137.33. So in 1 mole of barium sulfate, there would be 137.33 grams of barium divided by, I need to divide by the molar mass of the whole thing, so I'll just add them up here. I have 137.33 for the barium, plus 32.07 for the sulfur, plus 4 times 16.00 for the oxygen, and I get 233.40 grams of the whole compound. And I just multiply it by 100 to turn that into a percentage. So I'll do the division and multiply by 100. That gives me, looks like I got 5 sig figs here, 58.839. That's what we get there. And that is for the barium. Now the question asks us to do this for each element, so I can just do the same thing for the sulfur. Percent sulfur would equal, that'd be 1 mole of sulfur, so that's 32.07 grams of sulfur divided by 233.40 grams BaSO4, and I multiply by 100, so I can just plug that in. And I get 13.74% sulfur. Notice there that's just 4 sig figs because the molar mass of sulfur is 4. And then for the oxygen, that would be 4 times 16.00 grams of oxygen divided by 233.40 grams of the compound. So plugging that in, and I get 27.42% oxygen. When you're all done, the best way to check is to add them all up, make sure they add to 100. So if you add all these up, I get 99.999%. 99.999%. Well, it doesn't add to 100, so maybe I made a mistake. Well, not necessarily. You'll notice here that because of sig figs, the percentage of the barium went to 3 decimal places, and these only went to 2. So in that situation, a lot of times you won't get exactly 100. If I were to round that to 2 decimal places, this would in fact be exactly 100. So I most likely did it correctly. All right, let's take a look at the next problem. It says, find the mass percent, remember that's the same thing as percent composition, of oxygen in strontium nitrite. and we're given the formula there. So here we're just asked to find the percent composition of one element, the oxygen. If I look at the formula, I can see there are 4 moles of oxygen. So I want to do 4 times the molar mass of oxygen divided by the mass of the whole compound. So if you just figure the mass, the molar mass of strontium nitrite, that's 87.62 for strontium, plus 2 times the molar mass of nitrogen, plus 4 times the molar mass of oxygen, I get 179.64 grams for the molar mass of the compound. And I multiply it by 100. Let's see, we'll divide it by 179.64 times 100, and I get 35.63% oxygen. Alright, couple more example problems here. Number 3 is a little different. We are told when 221.0 grams of a gold oxide are decomposed, 24 grams of oxygen are obtained. Find the mass percent of each element in the compound. So here we're given actual masses. We're not just given the formula of the compound. This is from actual lab data. So what we're told here, we have 221.0 grams of some gold oxide. We don't know what the actual compound is. And we probably heat it up to decompose it. And when we do that, we get 24.0 grams of oxygen. Well, if you think about it, the rest of it has to be the gold. So if you take 221 minus 24, that's going to give you 197 grams of gold that were in that. And I could just use these values here to find the mass percent. So if I want to find the mass percent of oxygen, it would be 24.0 grams of oxygen divided by 221.0 grams of the whole compound. And that gives me 10.9% oxygen. And then I can do the same thing for the gold. Percent gold would be 197.0 grams of gold divided by the mass of the whole compound. So 197 divided by 221. And that gets us 89.1% gold. And those two would add to 100. So that should be correct. Alright, last example problem here. We're asked what mass of carbon is present in 10 grams of caffeine. And we're given the formula there for caffeine. So here, we actually need to use a percent composition. And because we're asked about to find the mass of carbon, first thing I'm going to do is I'm going to find the percent composition of carbon. I can see there are 8 moles of carbon in the compound, so 8 times the molar mass of carbon. Then I'm going to divide by the molar mass of the whole thing. So just calculate that here real quick. So 8 moles of carbon plus 10 moles of hydrogen plus 4 moles of nitrogen plus 2 moles of oxygen. I get 194.22 grams of the compound C8H10N4O2, and I multiply it all by 100. So 8 times 12.01 divided by the molar mass times 100, and I get 49.47% carbon. Well, remember what percent means. That it literally means per 100. So when I'm asked to find the mass of carbon, how many grams of carbon are equal to 10.0 grams of the caffeine, of the C8H10N4O2, I know that for every 100 grams of the caffeine, C8H10N4O2, that there would be 49.47 grams of carbon. Okay, that's the whole idea of calculating a percent and what it means. It is a conversion factor, as we've already seen. So I can just do the calculation. 10 times 49.47 divided by 100. And I get, let's see, that'd be 3 sig figs, 4.95 grams of carbon. Alright, the practice problems, I'd stop the video here, try them out yourself, and then see how you did. Alright, so the first practice problem, we're asked to find the percent composition of each element in sucrose. So it'll be percent carbon, percent hydrogen, and percent oxygen. So I have 12 moles of carbon, so 12 times the molar mass of carbon divided by the molar mass of the whole thing. So just calculate that here. 12 times 12.01 plus 22 times 1.01 plus 11 times 16.00. I get 342.34 grams for the molar mass of the whole thing. Multiply it by 100, so 12 times 12.01 divided by 342.34, and multiply it by 100, and I get 42.10% carbon. And I'll do the same thing for hydrogen. 22 times the molar mass of hydrogen over the molar mass of the whole thing. So I get 6.49% hydrogen, and then I have 11 moles of oxygen. So 11 times the molar mass of oxygen divided by the molar mass of the compound. And this gives me 51.41% oxygen. If I add them all up, let's see what I get here. I get exactly 100%. So we probably did that one right then. Alright, number 2. Find the mass percent of hydrogen in the compound propanol. So here I'm just looking for percent hydrogen, and I can see there are 8 moles of hydrogen. Notice how this formula is written. This is kind of common with organic compounds, not something we deal with a lot in this class. You can see there would be 8 moles of hydrogen total. These 7 here plus the 1, so 8 times the molar mass of hydrogen divided by the molar mass of the whole compound. Calculate that here. I get 36.09 grams. Oh, that's not right. I didn't include 3 moles of carbon. Let's try that again. 3 times 12.01 plus 8 times 1.01 plus 16.00. Let's try that again. That is 60.11 grams C3H7OH times 100 times 1.01 divided by 60.11 times 100, and this gives us 13.4% hydrogen. Alright, last one. What mass of dinitrogen tetroxide would contain 0.055 grams of nitrogen? So here's another problem where we're asked about how much of an element is in a compound, or compound contains a certain amount of elements. So here I need to use a percent composition. So we need to calculate percent composition of nitrogen first. So there's 2 moles of nitrogen in the compound divided by the molar mass of the whole thing. That is 92.02. So 2 times 14.01 divided by 92.02 grams, so I want to forget my unit, times 100, and that gives me 30.45% nitrogen. So what I can do here is use this as a conversion factor. I'm asked to find how many grams of N2O4 would contain 0.055 grams of nitrogen. So notice the units here, how this has to work. Grams of nitrogen has to go on bottom. So there's 30.45 grams of nitrogen in every 100 grams of the compound. So this gives us 0.18 grams in 2O4. And that is the end of the video.